Alright, so we are starting on some statistics. So this section we talk about mean, median, mode, and standard, or I guess mean, median, range, and standard deviation. So what we're given to start off with is Jamie McAllister is a wonderful rebounder for her high school basketball team. Her final 10 games, her rebound totals are as follows. Okay? It says collect the data, and what is the mean? So what we'd want to do for mean is the average. So I want to take every number here, and I want to add them together. So you would do 8 plus 12 plus 8 plus 11 plus 15 plus 6 plus 9 plus 8 plus 10 plus 13. And if you weren't told, you'd have to go through and count how many you had, but we do have 10 games here, so that simplifies things just a little bit for us. Okay, so we're going to calculate that out. When you add all those numbers together, you're going to get a 100 over 10, which is just 10. Okay? So that's how you calculate average. That's how your grades go in the grade book. Normally, it's an average grade. For the next part, we want to find the median. The median is the middle. So what you want to do is you want to line up all of your numbers from least to greatest. So I see 6, I see 1 8, 2 8s, 3 8s, a 9, a 10, an 11, a 12, and a 13. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, and a 15. 10. Okay? And what we want to do from here is we want to cross them out till we get to the middle. So I go from the bottom, top, alternating, bottom, top. In this situation, you see we have two middles. When you have an even number, if we only had 9 games, this wouldn't have happened, but when you have an even number like this, you simply add them together, divide by 2. So I would get 19 divided by 2, which is 9.5. Okay, so that is our median. Next is our range. Range is high minus low. So in this case, I would do 15, it's my biggest number, minus 6, which would be 9. And next we want to complete our standard deviation. So this is just like the X on the side here, right? It's over here. And then this X bar, this is your mean. So we calculated our mean previously to be 10. So to fill in this table, I would do, the first example would be 6 minus 10. That's negative 4. You want to keep in the negatives where applicable. 8 minus 10 is negative 2. I won't show all the calculations. 9 minus 10 is negative 1. 10 minus 10 is 0. 11 minus 10 is 1, 2, 3, and 5. Okay? The next thing we want to do is, we don't need to do a new calculation. All we need to do is now square this number. So negative 4 times negative 4 would give me 16 here. 2 times 2, or negative 2 times negative 2 is 4. All of my 2's will be the same. 1 times 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. And 25. And then I want to go through, and I just want to add all of these numbers together. So 16 plus 4 plus 4 plus 4 plus 1 plus 0 plus 1 plus 4 plus 9 plus 25, which would give me 68. So it's adding everything together. Okay? So now that we've done that, okay, we've done the bulk of our work here for our standard deviation. What we want to do is plug it into this formula. So what this formula is showing us is, this is what we just got, okay? So let's start to rewrite this. S equals square root of n minus 1. We'll talk about n in a second. But all of this weirdness here is what we did, where we added all these together. So that's actually where that 68 is going to come in. Okay? So even if this formula looks a little intimidating, you can do all this work. It's just a lot of addition. N is our number, like our total number, which for us was 9, right? Or 10. 10 games. So S will equal the square root of 1 over N minus, or 10, sorry, minus 1 times 68. Simplifying that, 10 minus 1 is 9. That's where the 9 was stuck in my head. We can combine our like terms. We get 68 over 9. And we can just throw this straight into our calculator and get out an answer. When I put it in the calculator, I got 2.75 as our standard deviation, which means per game, I can expect her to be within about 3 points-ish of her mean, which is, what was the mean? Our mean was 10. So I'm expecting her to be between about 8 to 12 points on average for a game. Okay? And these are going into a little bit of definition. So when you have a small outlier, when a small outlier is added to a sample, the mean gets, so the mean's that average. It's adding all your numbers together. You can imagine if I had 10 plus 11 plus 12, and I added in a 0, it's going to really skew my data and make it a much lower mean, so this would make it smaller. Okay. Range, on the other hand, if I think about range for this set right now, my range is just 12 minus 10, which is 2. But if I add in a 1, my range is now 12 minus 1, which is 11. So my range has gotten larger. So range will grow if you add an outlier. Okay? When a small outlier is added to a sample, the standard deviation, well, the standard deviation is going to get larger as well because there's more variance between your point scores. So it's going to increase my standard deviation. 8S, what is better center for these datas? So basically the question is, do I want to use the mean or median? Okay. So I have 18, 20, or 18, 19, 20, 20, 23, 26, and 260. So this is an example where you have a very extreme outlier. When we have an extreme outlier, we want to use the median. Because what the median does is it gets rid of that outlier. So it really helps us focus in our data and not get skewed by something so large. So when you have a big or a really small outlier, use the median. It's the better center of your data. Okay. So these are the mean weights and standard deviation for 2 samples of 6-month-old puppies of different breeds. So breed A, it has a mean weight of 42 pounds and a standard deviation of 2.4 pounds, which means, wow, these are big 6-month-old puppies, but that means that we expect a group of puppies to be between about 40 to 42 pounds-ish. B has a mean weight of 30 and a standard deviation of 4.8. So these puppies would be about 25 to 35 pounds. So blank, breed blank, has a higher average weight. Well, average is just a word for mean. And we can look at our means, right? 42 is definitely bigger than 30, so that would be breed A. Breed blank has a higher, or has weights that are more spread out. Standard deviation is your word for spread. Okay, that's a way to think about it. 42 or 4.8 is much more spread out than 2.8. That's almost a 5 pounds flux. If a dog that weighs 12 pounds is added to sample A, the new standard deviation is likely to be greater than, less than, or still equal to 2.4 pounds. Remember, standard deviation is your spread. So if I'm adding in a dog that's only 12 pounds and I'm expecting 42 pounds, that's going to spread out my data more. So what that's going to do is make the variance for my dogs be maybe 3 pounds or 4 pounds. So it's going to get greater if I add in a really strange outlier to my data set. Okay? So that is mean, median, standard deviation, and range. Let me know if you have any questions.